Okay, so we're still talking about quantitative data. And remember, when we talk about quantitative data, a distribution of quantitative data, we talk about the shape, center, the spread or variability, and any outliers. We talked about shape, okay, and the different types of shape. We talked about center and variability a little bit, okay? Like for variability, we talked about range, but there are other measures of variability, okay? For the center, I kept saying the middle of the data, which is really the median. Well, there's also the mean. So we're going to talk about specific measures. And certain measures of center go with certain measures of variability that we'll see in this lesson. So all I'm going to do is use this example here. Okay? We've got the salary of 12 employees at a company in thousands. So 39 is 39,000. So two main measures of center. Okay? One is called the mean, which you guys are all familiar with. Okay, really? Just the average. And how do we find the average of a set of numbers? We add them all up and divide by how many there are. Okay. We give a certain notation to the mean. And it depends, and we'll talk more about this in detail later. If we are talking about a mean population, okay, we would use this Greek letter called mu. If we are talking just about a sample of the population, we use X bar. So we would assume here that these are not all the employees of a company. Okay? We assume that there's more employees. So therefore, this is not the entire company. This is a sample. So I would use X bar. If this was the entire company, I would use mu. But again, we'll talk about that in more detail later. So fine.
For like so it's like what you're solving for is what you're saying. Like
Yeah.
You use mu or
Yeah, this when you see X bar, sample mean. When you see mu, population mean. Okay. Now the fancy notation, and you would get this on a formula sheet, although you really never have to use it, would be this. Okay. This is the capital letter sigma, capital Greek letter sigma. It means sum. All right, just, yeah. What was I reading? I saw some article on that about sigma males. In English, it's the sum of all values divided by, not the hashtag, the number of values. That's what that symbol means. Yes. So what we would have to do is we have to do 39 plus 34, and then I'm just going to save ourselves some time, plus dot, 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 all the way to the end, 29 plus 67, divide by 12 to get our sample mean. Okay? And our sample mean would be 601 divided 12, which is about 50.1. Units are very important with mean and median. So you could say 50.1 thousand, or you could say 50,100, either one of those. So you could say 50.1 thousand with the dollars, or 1.1 is $50,100. One or the other. Okay. You will always get this formula on the AP Stats formula sheet, but you'll never really have to use it. Okay, there are other ones. And plus, I'm going to show you towards the end here how you can use your graphing calculator to enter all the values, and it calculates everything for you that we're going to do. The median is the middle of the distribution. It's a number so that about half the numbers are smaller than the median, half the numbers are larger than the median. Now, how we find the median depends on how many numbers are in the list. If there's an odd number of numbers, there's one number in the middle. If there's an even number of numbers in the distribution, there are two numbers in the middle. So for example, like here, if I gave you 1, 2, 3, 4, 5, and asked you, has to be an ascending order or descending order, but we usually do ascending. Pretty easy, just tell me the number in the middle. It's 3. Okay. Because there's two numbers below 3, two numbers above 3. When we do an even set of data, though, there's going to be two numbers in the middle. So how you can calculate the two numbers in the middle, okay, get the middle number, and middle numbers in this case, because there's going to be more than one. Take how many numbers are in the data set, divide 2. That will be 6 is 1. The sixth number in ascending order is one of the middle numbers and one higher. The 6 and 7. To do a calculation to find, we would just do 5 divide 2, which is 2.5, and then round up. Third number is the middle. Okay. So that means if there's two numbers in the middle, I got 12 numbers in total. That means 5 are below and 5 are above. So 1, 2, 3, 4, 5. These two numbers are in the middle. And how do you determine the median from those two numbers when there's two numbers in the middle? Average them. Take the average. You get 34.5. So there's an odd number of numbers. There's only one number in the middle. That's the median. If there's two numbers, or sorry, if there's an even number of numbers, there's two numbers in the middle, average them to find the median. And remember, it's either 34.5 thousand or 34,500. Those are our two main measures of center. And we'll talk about, is one better than the other towards the end of this. So that's center. For variability, and whenever you hear the word variability, think how spread out. How spread out is the data? Nope. Sorry. Yeah. So you guys had asked a similar example earlier in this class about, okay, how can I find the center as accurately as possible. Well, we could actually do this more accurately now. Because if you think about it, we've got 55 ACT scores. We want to approximate the median, and they're from lowest to highest. A score from 9 to 12, 12 to 15, etc., all the way up to 36. What score will be the middle score in 55 of them? Which one will be in the middle? Well, 55 divided 2 and round up. 55 divided by 2 is 27.5. The 28th number will be the median. It's an odd number of numbers, so therefore there's only one median. So how do we count 28? Well, look at the frequency. Start from the lowest. There's 2 here. Add 3 is 5. Add 5 is 10. So the first 10 numbers are in these 3 bars. Add 7 is 17. So the first 17 numbers are in these ones. 17 plus 9 is 26. So the 26th number is in this bar, which means the 27th and the 28th must be in this bar. So we can be a little bit more accurate and say the median's between 24 and 27. The mean, best you'd be able to do is approximate the mean. Okay. It wouldn't be quite as accurate. I would say that the mean is either in this bar or perhaps in this bar, because there's a bit of a skew to the left. So the mean's going to get pulled a little bit, but the median won't. And we'll talk about that towards the end of this lesson. Okay. Range. Range, pretty straightforward. Range is the maximum value minus the minimum. We've talked about that. So in our example, it would be the maximum value of 185,000 minus the minimum value of 29,000, which gives us 156. Again, units. So you can either do 156 then the word thousand, or just write it like that. Where am I getting these numbers from? They're all based on this. We use the range sometimes, but the next two we use a lot more. This next one. Standard deviation. The standard deviation measures the typical distance each value is from the mean. Okay, so standard deviation, you need to know mean to calculate it. So it's the typical distance that's a measure of spread. If we have an idea of, on average, how much does each value is each value away from the mean? That gives us an idea of how spread out the data is. Obviously, the bigger the number, the more spread out the data is. The smaller the number, the tighter the data is. Okay. This you would get on a formula sheet again, but we can also use a graphing calculator. Again, if we are asked to find the standard deviation of the population, lowercase sigma. Good times. But if it's a sample, we do S of X bar. And it is equal to the square root. Yeah. That's standard deviation of a population. Yeah, I'm not going into a lot of detail right now. We don't have to worry about that right now. So it is the sum. You take every data value, you subtract the mean,
Oh my God.
add them all together, or square them, and then add them all together. And then we divide by how many numbers there are less 1. Again, don't worry so much about the formula. It's going to be the interpretation that's actually more important. So what does this mean? Let's just break this formula down. Okay. So why do you think we find the differences between each data point and the mean? So x1 minus x bar in the formula? Well, it's a measure of spread. That's the distance. Each value is from the mean. That's fine. The only problem with that, though, is to find the average. If we're going to add all those distances up and divide by how many there are less 1, and I'll explain the less 1 in a second. Okay. How do we deal with negative numbers? Because some of them could be positive, some of them could be negative, right? If a value is above the mean, its distance will be positive. If a value is below the mean, its distance will be negative. When we add them all up, they'll cancel each other out. We get nothing. So it's useless just to do this alone and add them all up, which is why we square them to make them all positive. So we square them to make all the distances positive. So we make all those numbers positive by squaring them, then we add them all up and divide by how many there are less 1. Okay? Why are we doing the same thing as median? Well, because we're finding to find the average or typical distance each value is from the mean. But remember, these numbers are squared. So how do I get back from squaring? Square root. That's why we square root. Okay. To undo the earlier squaring. Again, you don't have to know the breakdown of this formula. But that's essentially what we do. We're finding all the distances, positive numbers, averaging them out, and then taking the square root because we squared to make them positive. Okay. And in the end, it tells us the typical distance every value is from the mean. So if we go back to our salaries to find the standard deviation, we would have to, it would be a lot of calculations, which is why we want to use a graphing calculator, because it certainly saves us time. I would have to take the first value in the list, 39, subtract the mean. Remember, we found the mean on the first page to be 50.1 square. Then I'd have to take the second value in the list, 34, subtract the mean, square it. Then the third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, which would be the 11th one is 29 minus 50.1 and square it, plus the last number, which is 67 minus the mean of 50.1 and square it, and divide by how many numbers there are less 1. Take that square root. That's a lot of work, which is why I'm just going to give you the answer. Okay. And the answer is, works out to approximately, get an estimation, 43.61, which would be approximately $43,610. Interpretation. Typical distance each salary, because you have to write in context, each salary is from me. About $43,610. That's the interpretation. So whenever you are asked to describe standard deviation, interpret it. Look for the word typical. Typical distance. Another word for typical, average. So you could think typical distance, average distance, typically varies. Okay? All of those represent standard deviation. The reason that we do n minus 1 instead of n, okay? And you don't need to know this because this is actually beyond this course. But it turns out that, remember, this is a sample standard deviation. It turns out that whenever we calculate sample standard deviations, we're always just a little bit off from the actual population. And how do we correct that? We subtract 1. That's all. And you don't have to know that. Just know that it's n minus 1. Okay? Okay, last thing we're going to talk about here is the third type of spread, and this goes with the median. You need the median to help you do this. But in order to do this, you've got to break your data set up into quarters. Okay? And these are called quartiles. So the first quartile, when you have a list of numbers like you see here, the first quartile represent about a quarter of the numbers that are less. 3/4 of the number are 75% or above. The second quartile is the median, because remember we said the median, half or below, half or above. And the third quartile is a number so that 75% or 3/4 are below, 25% or a quarter is above. And when we get all those values, we find something called the interquartile range, which measures the variability of the middle half of the data from Q1 to Q3. Yeah, if you guys got to go anytime. I'm just going to finish this up. Okay. And then I'll revisit it again tomorrow. So what we want to do is we want to find the interquartile range of the 12 centimeters. Remember when we found, so we got to find the median first. Remember when we found the median, it was the two numbers in the middle?
Yes.
And the median was 34.5. The median is actually one of the values, is it? It's the average of two of them. So what we need to do now is I need to split the data up. Find the median of the lower half and the median of the higher half. Those will be the first and third quartiles. So when I do this, I take these and I find the median. That will be the value of Q1, the first quartile. Well, I've got 6 numbers. What numbers are in the middle? 34 and 34. So to find Q1, I have to average them. Well, that's easy. Q1 is 34. Yeah. And then I do the same thing above. I take the 6 numbers because I haven't included this. I included this in the calculation of the median, but it's not actually the median. So I have to include it in calculating Q3. What 2 numbers are in the middle? 39 and 43. When I average them out to find the halfway point, I get Q3, which is 41. Yeah. No, you can just split it up. Yeah. Yeah, unless it's an odd set, right? Like if it's an odd set, it's a little different. So therefore, the IQR, which we use for short, is going to be 41 minus 34, which is 7. And don't forget the units. $7,000. So yeah, you have to find the middle, and from there you have to find. Yeah, did I need to actually find this stuff? But what happens if it was an odd set of data? So let's say you had 1, 2, 4, 5, 6, 7. This would be the middle. There's only 1. So I don't include it when I calculate Q1 and Q3. Because that's an actual value. Okay, so you just got to know the difference. So then I would find the middle number of these 3, and that would be Q1. I find the middle number of these 3, and that would be Q3. So if it's an odd set of numbers, you don't include the median when you find Q1 and Q3. If it's an even set, you've got to include those 2 middle numbers in calculating Q1 and Q3. I'm going to stop there right now. How many of you have a graphing calculator with you right now? Good. I'm going to show you how you can find all this information in one shot. I'll tell you everything. Okay. First thing you need to do, and I always do this, I don't know if we have to do it for this one, but I'm going to do it anyway. Got to make sure your stats wizard is on. So you're going to press, you do not press stat, you press mode. I made a mistake. Still haven't corrected it. I meant to correct it last year.
Mode.
Press mode, which is upper left. Okay, so you're going to see normal, float, radian degree. Scroll down using the arrow keys on the right until you get to Stats Wizard. Stats Wizard. It's one page down. On. Don't worry about that. We'll take it one step at a time. Actually, let's turn that on too. Stats Diagnostics, turn that on as well. What's that? Okay, so to get out of that screen, go setting mode. That's quick. And that gets you back to a black screen. Okay. So now what we're going to do is we're going to enter the 12. We're going to enter the 12 numbers. How do you enter the 12 numbers? You go to Stat. Press Stat near the top. It's in the middle, near the top. You will see a screen that says Edit Calc Tests. Right now, Edit is highlighted along with number 1. Okay, you're going to hit Enter, and you are going to see columns. L1, L2, L3. Okay, if there's already numbers in yours, just like there is in mine, here's how you get rid of them. Scroll up until L1 is highlighted, and then press Clear. Enter. It should wipe them all out. You got to highlight L1 at the top. Yes, clear. Clear. Enter. Yeah, L2 as well. So under L1, we are going to enter our 12 numbers in the order that they were given here. So all you do is press 39, enter, and then it'll go down for you automatically. Enter. 34, enter. 34, enter. 35, enter. 34, enter, etc. They're on the front page of the lesson. These are the 12 salaries. What's that? What do you mean they're underneath? Why are you adding? I never said canvas. No. 39. Enter.
Oh, I have to be plus.
So all the numbers are in.
No.
Okay. All the numbers are in. Once you've done that, go second mode to quit. You get a blank screen, second mode. Okay, so now we're going to calculate. We are going to go back to Stat. You are going to hit the arrow key to the right to highlight Calc.
Okay.
And then number 1 should already be highlighted for you. Enter. Notice it's asking you list 1. Yes, that's what we want. We want to calculate all the stuff for list 1. Scroll down using the arrow down to calculate. It gives you, then enter, it gives you everything. So it gives you the mean, it gives you the sum, it gives you the sum squared, it gives you the standard deviation. And then if you keep going down, if you scroll down, it tells you the minimum value, it tells you the value of Q1, it tells you the median value, it tells you Q3, it tells you everything.
Thank you.
Okay, Which is why I said, don't worry so much about the formula, because if you're actually asked to calculate, that's the best way to do it, because you'll have all the information at your fingertips. Frequency, that's how it is.